good. So now we are talking about maps and the visualization of maps, to be more specific. What you see here is like just a regular map of the United States. On the left, you see the West Coast, San Francisco, and so on. And on the right, you see New York City, Boston, Philadelphia. In the middle is the Midwest, Chicago, Detroit, Atlanta is the South, and then Florida, and so on. So it's like a geographic map where the regions are highlighted, Great Plains, Inland West, and so on, right? And California here. So this is like the typical map, geographical, but that's not the only way you can see. You can use maps in a geographical sense. You can also map thematic issues on it. For example, this map here appeared in New York Times a while ago, and I use it here to show you like some interesting facts here. So this is basically about the city in like the way the regions were formed in the United States from a long time ago. Therefore, here you see the far west, and you can see here far west characterized by settlement largely controlled by corporations or government via deployment of railroads, dams, irrigation, mines, exploited as an internal colony to the lasting resentment of its people. So this is basically from the old immigration days, right, when the United States was formed, and even earlier. That's how people were sort of, thinking about people that lived there. Midlands, Greater Appalachia. So, for example, look at the Greater Appalachia, which is Dallas, Oklahoma City, St. Louis. If you read like what's about Greater Appalachia on the lower left here, settlers from war-ravaged Ulster, Northern England, lowland Scotland, deep commitment to personal sovereignty and individual liberty, intense suspicion of external authority. So basically, because of these people that moved there, these settlers that moved there, they came from certain areas, certain countries, Northern England, and they just moved away from England because they didn't like to be governed, and they really, really liked their liberty. And then here on the right-hand side, we see New Netherlands, which is now New York. Okay, the Dutch found it, retains traits of 17th century Amsterdam, global trading culture, materialistic, multicultural, committed to tolerance and freedom of inquiry and conscience. That's like New York. On the left, you'll see left coast, where you can read about, there's a New Englanders by ship and farmers, prospectors and fur traders from Appalachian Midwest by wagon. Yankee utopianism meets individual self-expression and exploration. So these are like basically El Norte here, Spanish American Empire far enough from Mexico City and Madrid to develop own characteristics, independent, self-sufficient, adaptable, and work-centered, right? So basically, these are sort of characterizations of these regions on the map, United States, that are like motivated by long history of the people that moved there. Now, what's very interesting is when you compare these maps, this particular map, to the voting patterns. This is from New York Times again, like same article. Try to basically create a connection between the maps here, like from what the origins of the conception is that the people have to live in these regions, and what they vote for. You'll sort of see, on the left here, California is mostly back then. This was the 2016 election, was mostly voting for Clinton, the Democrat candidate, and here Appalachian region was mostly voting for Trump. And so this is basically the two extreme, left coast and also New Netherlands, which is New York, also very heavily Democratic, and the other ones never lean. The other ones are sort of leaning towards Republican, and the other ones leaning towards Democrat. El Norte also pretty heavy, And then when you look at this, what's nice about this is these voting patterns, right? They relate almost exactly to those regions that were like motivated by just settling issues, right? You can sort of see New York is very open, multicultural, and wants to, very friendly to immigrants, and they seem to these people seem to be more in line with what Clinton was campaigning on, while these regions here, Greater Appalachia, don't hate sovereignty. They want to preserve sovereignty and don't want to be governed. They apparently, they were more correlating with what Trump was presenting, like the program that he was presenting. So these voting patterns basically can be related to the old geographical regions. I think it's very nicely seen by these maps, right? You can just compare those maps. You can see this map here and overlay the voting on it, and you can quickly see the correlation. You can almost predict what they vote for, and you can almost predict what message you have to bring to convince these people to vote for you. Right? So it's very, very interesting that there's the deep rooting in history. I thought there was an interesting example where geospatial visualizations can really quickly convey a message and then some insight in these kind of things. So that was one thing. Then another map that you're probably very familiar with is the satellite map. It's just satellite on Manhattan and then Queens and Brooklyn, right? It's just taken from the satellite with high resolution imagery. And then, you can see that. And then here's Central Park, for example, Reservoir, and then Upper East Side, Upper West Side, downtown, right? And here's Queens. And then you can go over and overlay the streets or the transportation on it. You see that the subway lines and the Metro North and all this stuff, you can sort of see, these are all connected. You can just flicker back and forth and sort of get a quick sense. So it's basically just use the satellite map. And then by the density of houses or buildings, you can sort of plan, traffic planners can then plan like where they need, where they need more subway lines and so on, or where they need more subway stops or the other things, right? So basically this sort of correlates into like another use of a map. This is a map that's a more hand-drawn map where just basically the, important things are being drawn, like trains and so on, right? And basically Taco Bell is this way. El Cane Memorial, this must be Los Angeles. So it's like a hand-drawn map superimposed on the real map. Maybe some things are a little shortened so it fits on the paper. But anyway, so that's basically, it says this is north. It's actually the opposite, right? North should be up, but it's south here. So you can, so this is basically, hand-drawn. And then this is what an automated route planner will give you, right? So if you want to go from here to here, well, this is Madison, and you can sort of Madison to what is this, Kalamazoo, and you can sort of just take this route, take it off the map, and just use this only. So you kind of sort of know this sort of highlights the critical points. So you sort of know you can focus on what you really have to do without being like distracted by the other stuff on the map, right? You clearly know you have to take this US highway, then you have to take a, left turn and a right turn here and so on. So you can sort of focus on your route and without being distracted by other things. So this is like another form of map, okay, where you just highlight the tasks, driving tasks. And this is the automatic generation of tours. Nowadays, this is, YouTube can, Google Maps can do this, right? Can quickly give you, like, you type in two locations, and then it actually creates a tour for you, right? I mean, this, I don't know, I don't think Google Maps can do this, but it can sort of select, you can sort of create a tour that visits all the landmarks. You can have like a nice sightseeing tour, so you can, like, here all the landmarks are shown. You can do this. Google Street View, you probably know this very well, right? You can sort of immerse yourself into the traffic acquired by these cars, have cameras on the roofs, reconstructed with computer vision. And you can virtually go anywhere, like you can go any neighborhood and just walk around there by clicking on these arrows. Very simple, right? And then street side view basically is a little augmented, right? Where it's like augmented with the businesses that are there. Like 4th Avenue, for example, there's these Martel and KeyBank, E-Trade, and so on. So you sort of know, you sort of learn a little bit about the neighborhood commercial wise. So this is like a augmented, and this is something we did in 2010. We call that street light view. Basically, street light view is like street view, but it tells you a little bit more about the illumination of different buildings. For example, assume you want to buy an apartment here. Then you want to know in New York City. Because I live there. Always wanted to know if when I buy an apartment, how much sun does this apartment get? And real estate agents, they always kind of lie to you. They always say, you know, there's lots of sun, you know, all day long, but it's not really true. You know, sometimes there's like a heavy building, a big building that occludes your apartment from the sun, and then you're in shadow for a while because of the winter. Maybe the sun is lower, you don't get any sun, or in winter the sun, or in the summer the sun is higher to get any sun. So you want to give so we developed this program that would analyze the scene using the sun patterns on different seasons, and just do computer graphics on that and measure how much rays will reach that window that you specify. For example, let's say I'm going to specify this window here and say, okay, how much sun goes there, right? And then the computer program will calculate how much direct sunlight I get and how much sun gets reflected on other buildings and goes into my window. So it's like a ray tracing computer graphics kind of program. And you can do this for any window because we have the map of New York City with the buildings on it. And you can also plan, for example, when they want to build a new building, how it will affect the other buildings around in terms of sun exposure. And then what we do, we make this glyph here, this what we call street light thumbnail, where you can sort of see between March and November, for example, but you can pick other intervals. And whenever it's bright, and this is the time of the day, this is like an overview of half a year time of the day, and whenever it's brighter, that window received more light. So here you can see there's like a period during the day when there is a large building that occludes the window from the sun. And so you can quickly sort of see it at night. Of course, in the morning there is not a lot of sun, and then during the midday here. And this apartment here has less sun in the afternoon. This one is more early afternoon, around noon, and this one has late afternoon. Okay, so then you can just look at these thumbnails and say, okay, well, I don't really want this apartment because I'm around a lot in the evening or in the afternoon, and I don't get any sun. But maybe this person says, oh, this is maybe better for me because here I have a lot of sun in the afternoon, but I'm usually not home in the morning or at noon, so this apartment may be better for me. Right? So this basically gives you some information on how much sun the apartment will reach. So we call that street light view. Actually, we have a patent on that, so no one's ever exercised it, but nevertheless, you can still wait. So it's interactive, right? And it measures both the indirect and direct sun exposure. Next thing is isopleth maps. Basically, this now uses lines to show data. This is here, for example, shows the lines of equal magnetic declination. This is by Edmund Halley, actually. It's very, very early, like from 1701. 1701 already someone made this, right? This is quite amazing. But it shows you the magnetic field strength. Okay. Then here, this is another one, shows you more the pattern of the streams and so on the sea, in the sea side. This is the topographical lines, like the how high the landscape is. This is 1,000 feet and so on. This gives you basically, each of these lines tells you equal height, right? And this basically, it's like slices that the hills, each line is basically a slice. Each curve is a slice. So this, the top of the hill is here, a small one. Topographical landscape. Choropleth maps. Choropleth maps, that is maps where you shade whatever however you subdivide the landscape, right? So here, this is France, this is Spain here, France, and this is Germany and Holland. And this is the map. This is actually the first choropleth map ever constructed, apparently. Uses the colors and shading to show the data. This is the illiteracy in France, okay? So the apparently black is more literate, and then white is, I think that's what it is. And so white means more illiterate than black means less illiterate. And what the other way around, I actually don't really know. So in any case, what it shows you basically, it uses shading to convey some values. Okay, it uses shading to convey some values. And this was like 1826. This was the first time someone did this. And then you can of course use this very often. It's being used very often. For example, here these are the counties of the United States. Each of these parcels is a county. And this is Kerry versus Bush, the election results in 2004. Kerry is the blue and Bush is the red. And it basically just tells you like which district, which county was won by who, won by who, whoever had the majority. Okay, so you see Bush had like a massive majority, like it looks like almost like the United States was dominated by Bush. But there's something wrong with this, because this is basically winner takes it all kind of thing. But this doesn't really truly represent what really happened there. Like you should really, look at it like this. So 62 million people voted for Bush and 59 million voted for John Kerry. This was George W. Bush and John Kerry. And then what's really the amount of red and blue is like 2.5 million square miles were colored Bush, and only 525,000 square miles were colored Kerry. So this is like basically an amazing, display of how you can lie with visualization, right? It looks like Bush is a dominating force in the United States, but it really wasn't, right? When you look at this, in terms of the, popular vote, we're almost the same. Okay, so better mapping is to map it by percentage. There's a percentage. So here, when it's really strongly red, the percentage was very high, and when it's faintly red or faintly blue, percentage was almost equal. Okay, so here, so you can see like basically only really there was some very strong Bush regions and some very strong Kerry regions, but most of the United States was sort of just between the two, right? 50%, 50-50, but most of them are 50-50. Okay, so so it's not that polarized. It's like very, very sort of even. So that's basically interesting. So this is by color, and this is even more informative, because this doesn't really give a clear message like how many people actually voted, because this is just percentage, but doesn't show you how many people actually voted. So what you can do is you can weigh it more by how many people actually lived in these areas, and you'll see like really a true representation of how what is the relevance of those votes, right? How popular the person really was, and you can sort of see the big cities mostly blue, and then large areas mostly red, right? So areas that are not very heavily populated clearly are more like Republican leaning, and areas that are heavily populated are Democrat leaning, right? So here, New York, and big cities like Chicago and Chicago here, Detroit, and so on, right? And Oregon, Seattle, and then LA and San Francisco, right? And then Dallas, Miami, and Tallahassee, and Gainesville. So you can sort of see this. This is really, so look at these three different maps, right? This is like the one where it's just binary. This is the one where you use percentage, and this is the one where you weigh it by population. So that you can if you do a little bit of data analytics, you can convey a much more truthful message, that really represents what you want to tell, right? If you only want to tell, who got the majority, then this is fine. If you want to be a little more truthful and really measure how many people actually voted, then you use this one, right? So it's just by visualization, you can actually give a very different impression. Okay. Then another one that I want to tell you about, you can also use height instead of, this is like a height basically. Use there. This is like basically a three-dimensional representation of what I showed you just here in 2D. Then another one is a different way you can do this is by looking, like by geographical distortion. So this is the map that I showed you before. This is basically just the states colored by who won them, okay? And now geographic distortion, if you distort the state by the number of people that live there, right? You'll see like, California has a lot of people live there, and these Oklahoma and so on actually doesn't have a lot of people. The Michigan, like Montana and so on, very sparsely populated. So basically they get deflated, and the states that have more people get inflated. And it gives you a little better impression of like how is the distribution of Republican versus Democrat voters, right? And you see like that all of a sudden what used to be very small is now pretty big, right? Because more people live there, right? So this is more like by population density, right? So now you see when you just look at the area itself and you just integrate the red color plus versus the red ink versus the blue ink, you'll see it's pretty balanced. Again, this brings back this point here, where you see that this is actually pretty balanced in terms of like the voters, 50% even, or like just plus minus 2% around the half point. This is about when you do it for counties. This is the counties. If you just use, if you don't, you can take into consideration the people that live in those counties, and this is where you take into consideration. So you can see this much more distorted, and the ink is much more balanced. But you can do more because remember, it's like oftentimes it's just 49 versus 51%. If you do this, then you color the map like this, and then when you distort it, it's like this. So it really looks like, everything's sort of purple, right? There's a little bit of some areas that are heavily blue, some areas heavily red. There's some, but not many people live there. But there's the purple color really sort of dominates, right? So it's just visualization, right? Basically, just try to convey a message in the correct way by distortion and by coloring, and by shading, right? So you can sort of really bring home a message much better and much more truthful than if you just, make an absolute value. But I think that was just an interesting study. Okay, this is just made the same map bigger. You can really see the rivers there and the lakes. So another one is like cartograms, where you just size up the area by the number of people that go to the fields, like the Elvis concerts, attendance per state in the 7 years, just by using size. It's like an early approach, so it's more like, it's more straight lines, not curved lines. This is interesting work by Jacques van Wyk. Take the map. Remember, like the map is like the world is a globe, right? So it's really hard to unfold. There's different ways you can unfold that globe and make it like a planar kind of thing. Cylindrical, azimuthal, and so on, conical, right? So there's different ways to sort of take that wrapper around the surface of the globe and make it folded out in such a way that it's area preserving. So I have this video here, which is very interesting to see. This is by Unfolding the Earth, Jacques van Wyk. It's a very interesting YouTube video to see, and I'll share it with you. Make it bigger. You can like unfold it like this. So you can basically use a focus point, right? You can sort of pick a focus point and fold everything around it. Similar to those graph networks that I showed you before. Here you take the polar region and unfold it around that. Here you take around the equator and fold it like that. Focus here on Africa. So you can, quite amazing, right? It's just a matter of where you cut the globe and unwrap it. I could watch that for hours. So you can have either view on you can isolate the continents, or you can from, here you isolate a continent. It's where you cut, right? Okay, so this was the myriahedral projections. Oh, hang on a second.
We live in a three-dimensional world. Everything we see and touch is a three-dimensional object, having a length, width, and height. Our planet is also a 3D object, a sphere. The problem is that most maps are in only 2 dimensions, length and width. Some 3D mapping tools are only simulations. There is no depth. That's the case, how can the Earth be accurately mapped? With an orange, the skin can be peeled and flattened.
Okay. Sorry, that didn't know what it meant. So, okay, this is the map lecture again. Okay, have to go here. Okay, so here we are at this unfolding again. So let's take this a little further, this ballooning that we talked about before. Okay, so here you see, this is like population-based map where India is much bigger and China is very big, and then here Europe actually is quite small, UK, United States, and these African countries are actually much smaller than they actually are, Indonesia. And then you take the same thing and you take it by GDP. You just take the same thing and instead scale it by GDP. And you'll see like America, United States has a very massive inflation because the GDP is so large. Same thing is here with Europe and UK. Like Europe is very big. This is Germany, France. And UK has an extremely high GDP. When you look at this, it's like expands like really massively. France too. It's very massive. And Switzerland also gets much bigger because it has a high GDP. While these sort of countries here, they get much smaller. China actually doesn't have a big GDP either. But here, this is Japan, massive. Like, look at Japan, how big it got all of a sudden. And then you can go and see, okay, like spending on healthcare, compare that. So Japan doesn't spend so much on healthcare, it actually shrinks. China spends more on healthcare, Then here, US sort of similar, right? A little bit. Mexico got smaller. You can sort of quickly see, here's the GDP again. Energy consumption, so US gets big again, what grows? Okay, this is China, this is Russia. Russia actually consumes a lot of energy with respect to healthcare. Healthcare is actually small. When you look at Russia here, it gets much bigger when it comes to energy consumption. Japan doesn't change. Actually, this one is very small in energy consumption. North Korea. Korea, actually, is this Korea? South Korea, right? South Korea actually doesn't spend much energy. That's interesting. I didn't know that. So, greenhouse gas emission has a lot, so Korea actually gets really big. So basically these sort of relational plots, right? These sort of where you scale up the countries by the amount they have in certain variables, gives you a really good impression, right? It sort of shows you the dominance with respect to the other countries. You can really see that by just using these scaling techniques. It's very informative. So you have these density equalizing map projections, just another form of this, like an earlier one that I just showed you from what I just showed you. This is the airlines view of the United States, where you have longer distances when the fare is higher. You'll see like Los Angeles, San Diego is very small, and then here go from the west. This is like from the 80s, I think, so you see this is from Atlanta, Georgia, right? So you can sort of, this all the airlines view now is from Atlanta, Georgia. So you can sort of see, which one costs more than others. So it's pretty, New York and DC, very similar flight price, Columbia and so on, and then up here it's much bigger, right? So you can sort of see this. So distort the map basically from how much it costs you to go to a certain area, to a certain city from your own city, which is Atlanta in this case. That's like just showing the population as a bubble. Nothing really, population on the map. Trafficgram is another way to show the connectivity of different regions. The rectangular cartograms is also a very sort of interesting way to show maps, because when things are sort of round and don't have like a linear shape, it's difficult to really figure out what the area is. So here you make them sort of on a Cartesian grid, so it's all Manhattan distance, right? It's either straight or vertical. No other lines are permitted. Gives you a little better assessment of like the real size. So rectangular cartograms, right? So this idea can be used more this is a tree map of the population, and this is like now taking these areas here and just lining them up so they're sort of adjacent on a real map, right? As good as you can by optimization. California is very big in population, Arizona, Nevada, Oregon, Washington. So it's kind of like, connected, how you would like be able to connect from California and to Washington. But at the same time, it's laid out in such a way that you can quickly assess how big these states really are in terms of the population. And it's squarified or almost squarified. Remember what I told you for the tree maps? When you make them squarified, it's easy to sort of get a good comparison between different things. It's not completely square because you want to like increase the connectivity of different states, but it's almost square, right? So you can really get a sense comparative how big the populations are with respect, like Ohio versus Kansas or Pennsylvania versus Washington, right? By doing this kind of thing. So it's basically take a squarified tree map and lay it out with the connectivity of a map. This is like really square, this like the grid map, and then colored by bans on same-sex marriage. This is like old data, and civil unions and broad domestic partnerships, but not marriage. That's basically just some data shown on a squarified geographical map, where the neighborhood relations are somewhat enforced, but you can only do so much because you only have 4 sites per state. So you can't, in some states maybe have 8 or 9 neighbors. It's kind of hard to do, right? Here it's a little easier because you make it more general. Here it has to be a square. But what's better here, you can make them rectangle, you can make them hexagonal shape. If you have more sites, you can share, right? So now you can really, California can now share its neighbors with Oregon, Nevada, Utah, and New Mexico can have 6 neighbors now, right? Colorado, Nebraska, Kansas, so you have this hexagonal shape. So now you can have more neighbors that way, right? So this basically is another way to lay out, states and make it more regular, easy to see, and it allows you to focus the color. Now everyone has the same size, and now you can use color to convey certain data, right? I don't know what it is here, but anyway, so this is basically a better way than the squarified. Squarified is good, but you cannot convey adjacency so easy because you only have 4 sites. Here you can convey adjacency much easier because you have 6 sites. Right? So this is another one of those squarified maps. Like here it's like Obama versus Romney. Just another example. This is another one of these somewhat hexagonal. This is now with counties districts. So it's again hexagonal shape or round shape. This is another example for this. This is an interesting map. Basically, it's a word cloud, but constrained by the shape of the United States, and it shows you basically which names dominate in certain areas of the country. So here's Smith and Miller in the middle. Then here are this is a Mexican name, Riviera and Rodriguez, Jones. It's like a word cloud, but this is just the North England and New England states up here, right? It's informative because you sort of know. So by looking at the last name, you can sort of get a sense for the population, the kind of population that lives there, in terms of the nationality and the racial profile, right? You can this is the Irish people live here. O'Brien, Smith is more English, Jones, more Rodriguez, more Hispanic, right? Sanchez Gonzalez Martinez. Is more Hispanic neighborhood, right? So it's very informative just by using these names, last names as a variable, as an indicator what lives there, who lives there. So this is the map of New York and New Jersey, based on the dominant race that lives here, right? So here you see white mostly up here in New York around Central Park, with a little bit of Asian between. Here's a lot of Asians, that's Chinatown, right? Also here Flushing and Queens, right, and so on, Brooklyn. Then here you see Hispanic, mostly in the Bronx. Harlem has a lot of Hispanics, some Asians. Here's black in the middle here, up here above Central Park, mostly black neighborhoods. Down Brooklyn also, you see black neighborhoods here, black neighborhoods here. So this is sort of, you just look at it and look at the colors, and you can sort of get a sense for like, what these neighborhoods look like, and then you can sort of get an idea, right? It's like a nice sort of visualization, and it's sufficiently accurate because you mix these colored dots. You can get a little bit of a sense of the composition of these neighborhoods. So here there's like Asians and whites are mingling together. Here Asians and Hispanics are mingling together. And here Asians and blacks are mingling together, right? So it's nice, and this is lowly populated here in Jersey, right? So, so it's, and here is more whites, here heavily populated. It's a nice sort of map, has a lot of different things you can see at the same time. Population density, racial profile, and in the geographical context, right? So it's really, really good way to sort of show this kind of information. You can use different things too. You don't have to do race. You can use education. You can use wealth. You can use whatever you like, right? It doesn't have to be race, right? It's just a matter of like, it allows you to see many different things at the same time and then draw conclusions from that. This is the flow map, tells you the transportation of passengers in Ireland. So that you can see Dublin, this is a very heavily frequented route. This is a less frequented route down south, right? And here, there's a lot of stuff here around Dublin, suburbs, right? So that's basically a flow map from 1837, right? So already in 1837, people did this by hand. This is Minard's map of Napoleon's campaign to Russia. We talked about it already, right? So there's the soldiers that go out to Moscow, and these are the soldiers who come back, right? You can see there's not a whole lot of soldiers came back. And you can also see what happened to them and where most of them got lost, right? This river, for example, here, a lot of people died by going across this river. So it's like another map, more of infographics kind of map. We talked about it in the earlier lectures. There's another flow map layout, California to New York, right? Sort of see the number of people that go there, Massachusetts. Another map. Time varying map, it tells you like how many people are traveling around certain time and where they travel, right? You can sort of see a lot of traffic here, not so much traffic here. And on the west and east west side, there's not a lot of traffic, but here the main arteries, you can quickly see them. It helps urban planners to figure out like, street parking and maybe also public transportation, and maybe where they want to charge people to actually go there to control rush hour traffic, right? There's a lot of information you can glean from this and use for future planning. Here, this is an interesting kind of approach. When often you tell someone 28 miles, but often people don't have really a sense what 28 miles really is. But if you show them a map, okay, 28 miles is the distance between you and Yahoo in Sunnyvale, California. Maybe the person, lives in Sunnyvale, lives there, but has to commute to Yahoo every day, right? So you tell them, okay, you have a clear sense how long it takes you to go from your house to Yahoo, and 28 miles is 3 times as much. Then you get sort of an idea of it, right? It's sort of contextualizing the distance. Or 28 miles is 8 times the distance between you and University of Washington, right? This could be like maybe you're going there a lot, right? So you sort of know how big that distance is, and 28 miles is 8 times more than that. And that gives you a little bit of an idea, like, okay, I guess it takes me half an hour to go there, then have to maybe calculate 4 hours to go to the other place, right? It's basically sort of a contextualizing information that you otherwise would be too abstract. You can contextualize it by something you know. It doesn't have to be distance, can be something else, or time. You can also contextualize time, or something you own, like it's like 5 times bigger than your car, or 5 times bigger than your computer, or whatever, or takes 10 times more energy than your smartphone. So it's basically something that you put it in relation to something that you know, and then this number makes a lot more sense to you. So in this case, it's a spatial analogy. This is an interesting map. It's a little outdated. MySpace, how big the community that uses MySpace is with respect to classmates.com, right? To basically take the data and grow a region on a map. So you can get a little bit from this. So basically, you know, maps. You can sort of see, oh, MySpace is really big, and then classmates.com is not so big. Friendster is not that big. You know, nowadays, of course, very different. Facebook is actually very small. It was a very old one, right? Nowadays, Facebook will probably dominate, and Twitter will dominate these maps. So this is also the last slide. Kind of interesting, right? When you sit here, the east, like east is really go towards Europe, right? And west is towards like California, right? And then Asia. But we call that usually the west, you know, which is very funny because this is actually east, but we call that the west. And while we call that the east, although it's in the western direction from you, from when you're here, right? It's kind of, you know, I don't know. It's always very interesting, right? You think of it as at the west, but it's actually east of you, and then this is on the west, but it's actually called the east. You know, so it's very interesting. So basically, this is sort of my last slide. I hope that has sort of opened your eyes a little bit on what you can do with maps and spatial information. We learned a lot about this. Right? We learned about, you know, this contextualization. We learned about how to, you know, convey dynamic data, like in terms of like, you know, flow and so on, like occupation. Then we learned about like how to map information on a map by dithering. That you can actually merge a lot of information in a single place, and then, you know, so on, right? So we talked a lot about this. This is also very interesting, this inflation of spatial regions. Yeah, that's also quite interesting, I thought. And sort of that you can do a lot more and with maps than just, you know, just look at geographical regions. Okay, so basically this sort of ends this lecture. I hope it was informative, so I will stop here.